Hello everyone, welcome to IGCSE Maths. In the previous video, we understood the theory of fractional indices. In this video, we are going to solve exam-style questions step by step. I strongly recommend that you pause the video and try each question yourself before watching the solution. So here is the list of questions that we will be solving in this video. Let's solve the first question. Here we have x raised to the power of 1 over 2 multiplied by x raised to the power of 2 over 3. So here we have the same base as x and we are multiplying. So I will keep the base same and then I will add the powers. So we know that 1 over 2 plus 2 over 3 gives 6, and this would be 3 plus 4, that would be 7 over 6. So here I can write x raised to the power of 7 over 6. Now there is a challenge for you. Currently we have our answer in the index notation. Can you convert it to the root form? Pause this video and try to convert this into the root form or the radical form. Let's see how we can convert this into the radical form. For that, look closely to this power. We have 7 over 6. To convert it into the root notation, we have to make the numerator as the power and the denominator as the root. So it will be 6th root of x raised to the power of 7. We can also write it as 6th root of x all raised to the power of 7. Both ways are correct. Now let's move to the second question. So we have y raised to the power of 4 over y raised to the power of 10 whole squared. Now first we solve inside the bracket. So we have y raised to the power of 4 divided by y raised to the power of 10 all squared. So here we have y as the base and we are dividing. So I will keep the base as it is and I will subtract the powers, right? And there I have the square present outside the bracket. So y 4 minus 10 is minus 6, and then the bracket and the square that is present outside the bracket. Now we have a very typical case of power of a power. So we will just multiply the indices. That would be y raised to the power of negative 12. And from the law of negative indices, we can simply write it as 1 over y raised to the power of 12. And that would be our answer. Now let's solve the third question. We have 1 over 2 x raised to the power of 1 over 2 divided by 2x squared. The first step in solving this question should be rewriting the division as a fraction. So I will write 1 over 2 x raised to the power of 1 over 2 divided by 2x squared. Now let's separate the coefficients. So we have 1 over 2 divided by 2, and here we have x raised to the power of 1 over 2 divided by x squared. Now look carefully, this part we have 1 over 2 divided by 2, that would be 1 over 4, right? The next part is this division. Here the base is same, that is x, and we are performing the operation of division. So I will keep the base x and I will subtract the powers. So 1 over 2 minus 2 is actually 1 minus 4 over 2, that is negative 3 over 2. So I will write 1 over 4 x raised to the power of negative 3 over 2. Now from the laws of negative indices, I can write this as 1 over x raised to the power of 3 over 2. Why? Because we know that a raised to the power of negative m can be written as 1 over a raised to the power of m. Now, I give you another challenge. Can you try to write your answer in the radical form? Currently, we have the answer written in the index form because you can see 3 over 2. This is the index, right? So can you change this answer to the radical form? Comment your answer. Moving on to the next question. Let's try to solve this. The first step here should be to convert this division into fraction. So let me rewrite it as the fraction. So we have negative 1 over 2 s raised to the power of 3 over 4 divided by negative 2 s raised to the power of negative 1 over 4. Now let me separate the constants from the variables. So we have negative 1 over 2 divided by negative 2, and then we have the variables as s raised to the power of 3 over 4 divided by s raised to the power of negative 1 over 4. Now look at this part, the constant coefficients. Negative divided by negative gives positive, so we can cancel out the negative signs. Then again we have 1 over 2 divided by 2, so that is nothing but 1 over 4. That is 1 over 4, right? And here we have s raised to the power of 3 over 4 divided by s raised to the power of negative 1 over 4. So that is division with the same base. So let's keep the base same, that is s, and now subtract the indices. So we have s raised to the power of 3 over 4 minus negative 1 over 4. Be very careful with these signs. Now this is 1 over 4 multiplied by s raised to the power of 3 over 4. This negative sign and this negative sign will be multiplied. It would be plus 1 over 4. Again 1 over 4 multiplied by s. 3 over 4 plus 1 over 4 gives 4 over 4. Now we have 1 over 4 multiplied by s. 4 over 4 is 1. So we have s divided by 4 as the final answer. Moving on to the fifth question. Look at this question very carefully. Here we need to first convert the roots to indices. Here we have the fifth root of a squared, right? Here. Now, if I ask you to convert this into the index notation, can you do that? Yes, that is very easy, right? To convert it into the index notation, we need to keep the base a, and then this power here, that is 2, it will be the numerator of the index, and this root 5 would be the denominator. So it would be a raised to the power of 2 over 5. In the similar way, this cube root of a raised to the power 5 would be a raised to the power of 5 over 3. Now in the original expression, I can replace the values like a raised to the power 2 over 5, all raised to the power of 3 over 2, multiplied by a raised to the power of 5 over 3, all raised to the power of 1 over 5. Now this is power of a power, so I will just multiply the indices. Here also we have power of a power, so let's just multiply the indices. 2 and 2 will be cancelled out. It would leave us with a raised to the power of 3 over 5 multiplied by, here also we can cancel out 5, so we will have a raised to the power of 1 over 3. Now we have the base a and we are multiplying. So let's keep the base as a and then just add the powers. 3 over 5 plus 1 over 3 is actually 14 over 15. I am assuming that you can add these fractions. So a raised to the power of 14 over 15 will be the final answer. Moving on to the next question. Here, to solve this, we need to rewrite everything in the index form. Let's see how we can do this. Here, this cube root can be written as x squared y all raised to the power of 1 over 3, because cube root is actually the power of 1 over 3. In the same way, here in the denominator, we can write xy cubed raised to the power of 1 over 2. Now, we have powers outside the bracket in the numerator as well as in the denominator. We know that whenever there is a power present outside the bracket, that power is applied to everything that is present inside the bracket. So, look carefully here in the numerator. This power of 1 over 3 will be applied to x squared. So, x squared raised to the power of 1 over 3, and this y will also have the same power of 1 over 3. With the same logic in the denominator, we will have x raised to the power of 1 over 2 and y cubed raised to the power of 1 over 2. Now, let's simplify it. Here we have power of a power, so x raised to the power of 2 multiplied by 1 over 3. Then we have y raised to the power of 1 over 3. In the denominator, we will have x raised to the power of 1 over 2. And here again, we have power of a power. So we will multiply the indices. So it will be 3 multiplied 1 over 2. Let's rewrite it. We have x raised to the power of 2 over 3, y raised to the power of 1 over 3, and here we have x raised to the power of 1 over 2, and here we have y raised to the power of 3 over 2. Now we can simplify this. Here the base is same as x, so I can just keep the base as x and subtract the indices. In the similar way, we can also keep the base here y and subtract the indices. This subtraction will give 1 over 6, and this here would leave us with negative 7 over 6. So that here is our final answer for this question. If you want, you can change this in the root form or the radical form. That would be valid. Moving on to the next question, solve for x. So we have an equation here that is 3 raised to the power x is equal to 81, and we need to find the value of x. So in these type of questions, we need to keep the base same everywhere throughout the whole question. So here in the left hand side of the question, we have 3 raised to the power of x. That means 3 is the base, and at the right hand side we have 81. So we need to rewrite 81 as a power of 3. So let's see how we can do that. So we have 81, and we can see that 81 is actually 3 multiplied by 3 multiplied by 3 multiplied by 3. So that is actually 3 raised to the power of 4. So we are successful in our endeavor. We can write 81 as power of 3. So going back to the equation, we have 3 raised to the power x equals to 81, and 81 is 3 raised to the power of 4. So on comparing both sides of the equation, we can actually deduce that x is equal to 4. And that is the solution for this equation. Now this next question we have is quite similar to the previous question that we just solved. So here in the left hand side we have 2 raised to the power of x plus 3, and that is equal to 1 over 16, and we need to find the value of x. So remember what I said in the previous question. We need to keep the base same throughout the equation. In this equation, in the left hand side, we have 2 raised to the power x plus 3. So 2 is the base. Now, look at the right hand side of this equation, we have 1 over 16. So can we write the right hand side of the equation as powers of 2? So we know that 16 is basically 2 multiplied by itself 4 times, right? That is 2 raised to the power of 4. So we are able to write 16 as powers of 2. So let's go back to our original equation. We have 2 raised to the power of x plus 3 equals to 1 over 16, and now 16 is basically 2 raised to the power of 4. Now again, we know that if we want to move this 2 raised to the power in the numerator, I need to change the sign of the index. Why? Because the law of negative indices says that if we have a raised to the power of negative m, then we can write it as 1 over a raised to the power of m. So using the same law, I can write 1 over 2 raised to the power 4 as 2 raised to the power negative 4. Now you can compare both sides of this equation and you will see that this x plus 3 is basically being substituted by negative 4. So this x plus 3 must be equal to negative 4. To solve this equation, we need to subtract 3 from both sides. So it will be x is equal to minus 4 minus 3. That would be negative 7. So x is negative 7. And that is the solution of this equation. Now let's solve the next question. We have 64 raised to the power of x equals to 2. And we need to find the value of x. So clearly here in this question, it is difficult to write 2 as powers of 64. But can we write 64 as powers of 2? Yes. Let's see how we can do that. So we have 64, and 64 can be written as 2 multiplied by 2, again multiplied by 2. So if I multiply 2 by itself 6 times, so that would give me 64. So 64 is actually 2 raised to the power of 6. So what happens if I replace 64 with 2 raised to the power 6 in the equation? Let's see. Now let's go back to the original equation. We have 64 raised to the power of x equals to 2, right? So now I will replace 64 with 2 raised to the power of x. So 64 is actually 2 raised to the power of x. And then we have this x present outside the bracket equals to 2. So this is actually power of a power. So I will just multiply the indices. And 6 times x is 6x. So I have 2 raised to the power 6x equals to 2. Let's not forget that there is a power of 1 present here, right? Because 2 is actually 2 raised to the power of 1. Now, if you compare both sides of this equation, you can see clearly that this 6x should be equal to 1. So we will write 6x is equal to 1, and that would give us x is equal to 1 over 6, and that would be the solution of this equation. Let's move to the next question now. Here we have x minus 1 all raised to the power of 3 over 4 equals to 64. So if you have already tried to solve this question, I think you will agree that the biggest hurdle in solving this equation is this fractional power of 3 over 4, right? So it creates difficulty. So what if there is a way through which we can remove this fractional power? Would that make that question easy? Let's try to remove this fractional power and see how we can solve this question. So raise both sides to the power 4 by 3. So the first step would be raise both sides to the power of 4 over 3. Why 4 over 3? Let's see. X minus 1 raised to the power of 3 over 4 equals to 64. Now the first step says raise both sides to the power 4 over 3. So let's apply the power of 4 over 3 to both sides of this equation. Since we are raising the same power to both sides of the equation basically does not change. So look carefully here. We have a power of a power. So we will multiply these indices. So we have x minus 1, 3 over 4 multiplied by 4 over 3. And at the right hand side of the equation we have 64 raised to the power of 4 over 3. Now look closely here. I can cancel out the 3's and the 4's, and that would leave me with x minus 1 raised to the power of 1. And here I still have 64 raised to the power of 4 over 3. Now, can we solve or simplify the right hand side of this equation? 64 raised to the power of 4 over 3. You can write 64 as 4 multiplied by 4 multiplied by 4, right? And then this power of 4 over 3. 4 times 4 times 4 is basically 4 raised to the power of 3. And then we have 4 over 3 present outside the bracket. So again we have power of a power, so we will just multiply these indices. 3 and 3 will get cancelled out. That is 4 raised to the power of 4. 4 raised to the power of 4 is 256. Now we can go back to the equation. We have x minus 1 raised to the power of 1. We can omit the power of 1 because it will not change the value at all. So we have x minus 1 equals to 64 raised to the power of 4 over 3. We just found out that that is actually 256. 56. So at the right hand side, I can write 256. Solving for x will give 256 plus 1, and that is 257. So 257 would be the solution of this equation. So that is all for today's video. If this video helped you, make sure you revise the theory of fractional indices as well. Thank you for watching ACE Maths.